Welcome to the University of Utah's CS4400 Lab number 12 video. I'm going to work through the friendlist web server and see how it works and add some functionality to it. We are going to start by just simply seeing the friendlist server operate. So we're going to build it. And we're going to go ahead and run it. I'm going to use port 2112 as that is within the range that's allowed by the CADE lab. And once I start this server, it doesn't give me any information. It's just simply running, waiting for a request to come. So let's go ahead and generate a request. I'm going to use the curl program. And I'm going to send it a request to localhost. That's where the program is running, is on the same machine using the port I specified. And then I'm going to go ahead and execute this and see it work. Two things. First, you can see both the request and the response as debug information from the server. And the second thing is you can see that curl received the data and displayed it on the screen for me. You'll notice that Bob doesn't have a carriage return. This is fairly common for data that is sent back, a response sent back from a web server. Now, one of the things we need to do is actually send information, data, to the web server so that it can process it. So we're going to change the URI that we're using here. We're going to go ahead and follow the instruction. We'll use befriend user equals me ampersand friends equals Alice. All right. Now, you'll notice that I'm surrounding the URI in quotes. This is because I'm using curl. Curl is a command line program. And bash handles the ampersand character, this little fellow right here, a little bit differently outside of quotes. It treats it as a backgrounding. It backgrounds whatever command you're specifying. But we don't want that to happen. We want the ampersand to be treated as a character for the URI. So we need to surround the URI in quotes so that bash doesn't interfere. In any case, I run this, and now you can see that the server response, or the debug information, has user equals me and friends equals Alice. It separated all this information out from the URI for the server to use. So let's take a look at how that works. So I'm going to go ahead and edit the code. Now, the first thing, let's just step through this a little bit. Main is fairly simple. All main has is an infinite loop here, accepting connections, and then calling this doIt function to allow it to work, to allow it to do its job, and then closing the connection when it's done. So let's take a look at doIt. Inside doIt, it starts by initializing the Rio library, the readInit function here, and then Rio reads a line from the request. We're going to use that helper function to get some work done. Now, once it has the request, a line, it goes ahead and parses that request just to separate out the method, the URI, and the version. You can see that in the debug information right there is the get. Most URL or URI requests are get requests. Here's the URI itself, including our parameters, the user equals me, ampersand friends equals Alice, and then the version. This is actually the version of HTTP that the client is using to communicate to the server. And the server can use this information to properly format the data. When that particular request has been parsed into its three parts, there's some checking to go on to make sure everything's fine. But then here in lines 88 and 89, we create a dictionary. This dictionary allows us to take the URI and separate it into its various key value pairs inside the dictionary. If it's not a post, we do, or if it is a post, there's a post query here, but we don't do a post, we're doing a get. So for debugging purposes, we print out the dictionary, which is why this information is displayed. That information is printed out because that print string dictionary is being called. But then we have the serve request. Serve request is where most of the work happens. So let's take a look at that. Here's the serve request function. Serve request function is really simple. All it's doing is creating a body, which in our case is the data that we finally have output here, the Alice and the Bob. And then it's creating a header. This header is actually sent to the client using the Rio write_n, or write_n bytes function. So it's just simply sending this header string to the client. After the header string is sent and freed, then Rio write_n is called for the body. So fairly straightforward. Just simply create a body, create a header, and write them both out. So what we want to do is we want to create a function that is going to allow us to do the following. So I'm going to go ahead and real quickly, we're going to try to use this greet function. So I'm going to go ahead and say greet question mark user equals John. So right now it's still doing the serve request just as I specify, just as it's written. So let's go ahead and add some functionality here. Back up here in the do it function. But now instead of just serve request, I'm actually going to tell it to check the URI for a particular string. We'll use the handy library function starts with, and we'll say, does the URI start with greet? Notice I put the slash in there because that's part of the URI. So if it starts with greet, we're going to go ahead and call a function we're about to create called serve greet. Otherwise, it's just going to do exactly what it was doing in the past. So it won't be any different if I use befriend or whatever other function there exists. Now, at this point, we need to declare and define the serve greet function. So I'm going to come up here to the top of the source code, and I'm just simply going to copy serve request, but rename it to serve greet. All I'm doing is changing the name. I'm leaving the parameters alone. Everything's still the same. Now, down here where serve request is defined, I'm going to go ahead and copy this entire function and make a duplicate of it. But what I'm going to do is I'm going to rename the function, obviously. Now inside this particular function, I'm going to want to do whatever greeting I expect to be going back to the client. So for right now, I'm just to make sure that I've got the condition in do it properly set up and that serve greet works, I'm going to go ahead and just simply return greeting. So let's go ahead. We're going to stop the server using Control C. I'm going to go ahead and run make to build the friend list program, and I'm going to rerun the friend list program with my port number. All right, so I'm going to resend that URL, the greet user John, and hopefully I get something different back. And I do. This time I get greeting back, which is what I was hoping for. Now I can see that this code is being executed. So what else do we want this particular code to do? Well, for one thing, we need to get data from the dictionary, which is being passed into my function. I need to get that data from the dictionary so I can use it. I'm going to go ahead and define a new variable. But this variable is going to contain a pointer to a string that I get from dictionary get. So dictionary get, and dictionary get takes two parameters, the dictionary itself, so query, and then the key for the value I want. In this case, the key is user. After that function is called, if user is a key in this particular dictionary, I should get the proper value back. I'm also, instead of just simply creating a static string for body, I'm actually going to build a string using the append strings function. Append strings takes one or more strings. So greetings, then I can pass it the user value that I received, end it with a quote, and then pass it a null terminator, letting it know that that's all the strings I've got. So now I get the user value that was set, the value of the user key. I build this string into body, and it should send it back to the client. So I'll write this, stop our server, make it, run it, and let's try that URI again. And there you can see I've taken this value and I've passed it into my program, and my program can return it now. So that is how you get a value from the URI into the server so that you can process it for whatever purpose you need. Now, I do want to point something out here in the code. Clearly, I am creating a new string here with this append strings function. The value that's returned by append strings was allocated within the append strings function. That allocated data needs to go somewhere. I am sending it here as data that is written, or write n, to the client, but afterwards it's freed by the body. Now, this is all fine and dandy. If I take a look at my server, I'm going to run my server with valgrind now. And let's go ahead and send it John, and we'll send it Aaron, and we'll send it Arthur. So lots of proper values being returned. But if I go to the server and stop it using Control C, you can see here that everything is cleaned up properly, just like it's supposed to. There's no blocks allocated, no bytes allocated. But that's simply because we're freeing the data as we're supposed to. Now, what happens if I take this out and try to run my server? Make, Builds fine. It doesn't see any problem. Run my friend list with the Valgrind. And let's go ahead and try these again. Now the server runs fine. It doesn't see any problems. But as soon as I terminate the server, Valgrind kicks in and lets me know, hey, you've got 3 blocks that were allocated. There's a total of 50 bytes that have leaked in this program. And it has leaked because this particular program is not freeing all the data it's allocated. The lesson we learned from this is make sure that when you allocate something, whether it is via append strings or stir dupe as we had before, or whether it is when we create headers to send back to the client, in this case the OK header, make sure that each one of those is freed appropriately after use. And you can of course use Valgrind to help you in that task, to make sure you've got all the data cleaned up. This is especially important in server programs where they can be running for long periods of time. They don't just simply terminate and automatically clean up their memory. This simply accumulates over time and can cause serious problems within your system. This is the end of the Lab 12 video.